Hi, welcome to the fourth class of Acids and Bases, which is the eighth topic of IB Chemistry. Please look the question. This is related to an indicator. That means we know that indicators are in general weak organic acids or weak organic bases, which will be in the ionized and non-ionized form, creating distinct color. So that is a related question here. An acid-base indicator HIN dissociates as per the equation HIN, reversible arrows, a proton, aqueous medium, and the IN minus. HIN is having color A and the IN minus is having color B. Color B is for the conjugate base of this acid. HIN means an acid and it will form IN minus ion, which is having color B. Which statement about the indicator is correct? We have three statements here. I will read for you. The first statement is, in a strongly acidic solution, color B is seen. Second statement is, in a neutral solution, we can say that the concentration of HIN indicator is equal to the concentration of the conjugate base IN minus. Third statement is, HIN, the indicator, is suitable for weak acid against weak base titrations. So we have to opt whether A, B or C, A, B, C and D, which option is correct? One only, two only, three only, or none of the above? Or just look and think about this. From the question itself, we have some clue. That is, it is mentioned as a reversible equation. A reversible equation indicates, as we expect, it is either a base or an acid. Since HIN is there, a reversible equation at equilibrium indicates that HIN is a weak acid. For strong acid, there is no equilibrium. Only forward arrows there, reversible, and it is a weak acid. As I have told you, indicators are in general weak organic acid or weak organic base having distinct color for ions or ionic and non-ionized form. We know various indicators like phenolphthalein, methyl orange, thymol blue, etc., which are used for titrations in the +2 level or higher secondary level itself. So let us be quick in deciding whether 1 is correct, 2 is correct or 3 is correct, and thereby answering the questions. Everybody knows what is Le Chatelier principle. For the first option, Le Chatelier principle is applicable. I will tell you what is Le Chatelier principle. If a system is at an equilibrium and if you change temperature, pressure, concentration, etc. of a system at equilibrium, then the system will adjust in such a way so as to cancel the effect of change. So if you are increasing the temperature, the system will try to decrease it. If you are increasing the number of molecules, the system will try to decrease the number of molecules. If you are increasing the pressure, the system will try to decrease and reverse it also. So whatever you are changing, the system will try to defend it. And that is called the Chatelier principle. So see the statement, in a strongly acidic solution, color B is seen. What do you say about this? In a strongly acidic solution means we are adding more acid and already there is H positive aqua here. So what the system will do? If you are adding acid in the system, system will try to decrease the acid concentration. How to decrease the acid concentration? By combination of the conjugate base and the H positive. The HIN undissociated molecule will be formed, which is having a color A. Color B is for this indicator. This for this indicator. So we can say it is a weak acid, and this is the conjugate base of that acid. So according to this equation, Le Chatelier principle, in a strongly acidic medium, that means more H positive if you are adding, the system will be going to the left side. More and more H positive will be united, and color A will be there. Color A will be developed and no color B is formed. So question number, this statement is wrong. I think you have followed. This is a strongly acidic medium. Therefore, according to this equilibrium equation, the shift of the equilibrium will be towards the left side, that is the reactant side, and color A will be predominant. And let us see what is the second option. Second option. In a neutral solution, the statement is that the concentration of HIN will be equal to concentration of IN minus, or in short, the concentration of indicator and the concentration of the conjugate base will be equal. Let us think about this. Neutral solution itself indicates that pH is equal to 7. So it goes without saying that during that condition HIN will be approximately equal to IN minus, because this equilibrium is not at all influenced by external agencies of a base medium or acid medium. So it can attain a situation if no other conditions are there. This can be true. HIN concentration can be approximately equal to IN minus concentration, and the indicator color is what? A combination of A and B, and not a distinct color is formed at a neutral medium. So the purpose of the indicator is not served properly, because we have a combination of color obtained. Instead of color A or B, we have A plus B. A combination is obtained in neutral solution. We will go further and think what will happen if the HIN concentration is 10 times than of IN minus concentration. If HIN concentration is 10 times more, we can say that color A will be predominant. HIN is more and color A will be predominant. And as we have already said, if HIN concentration is equal to IN concentration, that is the ratio is equal to 1, then we have mixed color of A and B obtained. And on the other hand, if HIN divided by IN minus is very much less than 1, that is 0.1, then color B will be dominant, because IN is more concentration. IN is 10 times greater than HIN, and the IN color will be color B, will be developed. On that basis, we can for time being accept in a neutral medium HIN is equal to IN minus active mass or concentration. So this type of question we have to also think about the third statement. The third statement is HIN is suitable for weak acid against weak base titration. In fact, the indicators are not suitable. The organic origin indicator, weak organic acid or weak organic base indicators are not at all suitable for a weak acid, weak base titration. Why? The titrations involving weak acid and weak base are complicated. Why? Due to the hydrolysis of both cation and anion of the salt formed. The salt formed will be again undergoing hydrolysis, and it is difficult to determine the equivalent point. In that situation, the equivalent point cannot be clearly determined. We have only a range of that, a wide range. Sharp endpoint is not obtained, or concordant value is not obtained. We will have only a range of that, which will be clear from this small graph here. This graph is a plot of pH against a volume of base. We can see a steep portion here, steep part of this curve. This steep part of a curve is ranging between the pH 4 and 10. And any indicator will work as an indicator only if it is having pH range 4 to 10 color change. 1 ion to the combination, the color, distinct color will be there between 4 and 10. Then only it can act as an indicator. Our example is methyl orange and pH phenolphthalein will serve the purpose. It is having a sudden change in between the pH range 4 and 10. But in the case of thymol blue, this color change is below 3 pH, and you can see a wide range. Instead of sharp point, we have a wide range, and using this titration method, we cannot determine the end point exactly. So, titration involving weak acid and weak base are complicated due to hydrolysis of both cation and anion of the salt formed, and any normal indicators are not at all suitable for that purpose for measuring. It is difficult to determine the equivalent point also. So, indicator change color over a pH range. pH is equal to pKa plus or minus 1. You know already what is Ka. Ka is the acid ionization constant. So, log Ka minus log Ka is equal to pKa plus or minus 1. Then only if the color change is between 4 and 10 pH, the indicator will work as a good indicator, and it is seen that HIN is not suitable for weak acid weak base titration. This also is wrong. So what is the conclusion? What answer will be there? If an answer is to be selected, then we can say that B is the correct answer. In strictly speaking, we can also say that none of the above is a correct answer. So it is left to the students, they can select B on this background and D if it is not satisfied. So in that situation, we will select the best answer, that is B. So B is the correct answer. We will continue in the next class. Bye.